Hello, welcome back to Mrs. Torres' YouTube channel. Today we are on the second page of our Chapter 4 notes. Up the top here it says, the vertex is a point that joins two sides of a triangle. In the triangle below, so we're looking right here, the vertices are A, B, and C. So that's just some vocab, some good vocab to know. And then the side across from the vertex or angle is called the opposite side. So let me show you what I mean. So we're going to name the side opposite of each angle. So let's look at A first. So A is down here. If I were to start my pencil at A and draw a line straight across, the side that I would hit would be BC. That means that's the opposite side. So BC is opposite of A. If I do the same thing for B, I draw a straight line down, I hit AC. So that means that side is opposite. If I start at C and go the whole way across here, the opposite side is AB. Now, one thing I want to say about opposite sides, they're lengths, so opposite side lengths, and angle measures correspond. So those two things correspond. This is what I mean by that. So let's say angle A is the largest angle in this triangle here. So A is the largest angle. That means that the side across from it, so BC, is the longest side. Let's pretend like C is our smallest angle. That would mean AB is our shortest side. So that's what I mean when I say they correspond. All right, let's look at classifying these triangles here by its sides and angles. Traditionally, you would see the angles word come first and then the sides. I won't be too picky with that, though. So let's look at the angles here. We've got 75, 75, and 30. Those are all acute, so we have an acute triangle. Now let's look at the sides. We have 4.1, 4.1, and 2.1. We have two equal sides, so that means it's an acute isosceles. Number 2, I see that angle 110. As soon as you have one obtuse angle, we can classify this as obtuse. And we know none of these sides are equal because none of our angles are equal. Because they correspond, let's just pretend like for a minute that this angle was also 30 degrees. That would mean opposite sides are equal. But that's not true for this one. So this is an obtuse scalene. Here we see the right angle, so we know it's right. And then we have no tick marks telling us that we have equal sides, so it's scalene again. And the last one here, these tick marks tell us that it's equilateral. Now, if we think about what we know about the corresponding, since all of our sides are equal, that would tell us all of our angles are equal. So it's equiangular as well. But we know as soon as we have one, it's the other one. And then last one, draw an acute scalene triangle. So yours is going to look different than mine, but if I draw something that looks like that, all my angles are acute, and then those tick marks tell me all the sides are not equal. All right, if you flip it on over, I want to do just the first 3 problems here. So this is talking about triangle sum theorem. So the sum of the measures of the angles in a triangle is how many degrees? Remember, sum, we're talking add. adding. So this means if we add up all the measures in a triangle, that's going to be 180 degrees. So any triangle in the whole wide world, all the angles will always add up to 180. So let's take a look at this first one. We know all three of these are going to add up to 180. So if we take 180 and subtract out the angles that we know, we will get 58 degrees. So that means this angle here is 58 degrees. Number 2, we know this angle up here is 40. What do we know about that angle? We see that box there. That means it's 90 degrees. Again, to find the missing angle, we can take 180 and subtract out the two angles that we know, and you would get 50 degrees. Number 3, we are going to use that same idea, but we're going to put some algebraic expressions in there. So we know if we add these three up, they're going to equal 180. So let's write an equation that says that. So x plus 59, that's this top angle, plus x plus 51, that's this bottom angle, plus 84 equals 180. We know that's true. All right, let's combine some like terms. We'll get 2x equals, if we add these three up, you should get 194. Then we just solve it. So subtract 194. You'll get 2x equals negative 14. Divide both sides by 2. You should get x equals negative 7. Now, what if I asked you, what's the measure of this angle here? We would take this 7, plug it in there. So it's okay that we got a negative number for our x as long as we don't get a negative angle. We can't have negative angles in our triangles. We can have a negative x, however, because if we plugged it in here, this angle would be positive 52. All right, thanks for watching.